If you're using Linux OS, we'll be using Git to get the rpyboot source code. Please ensure that Git and libusb are installed following this command. And then clone the USB boot tool repository and see the downloaded directory. To compile and run the USB boot tool, enter the following command. It will wait for your connection, and once you connect the board and power on, it will discover the compute module and send boot code to allow access to the device. If the USB device doesn't show up when you run the USB boot tool, please make sure that your board and your host computer have been connected properly. If you didn't realize there was a boot button on the different side of the board, please note that you need to hold the boot button while you powered it on. If you already have power on, hold the boot button and then press the reset button. It'll solve most of the problems when you boot the CM4, but if it still doesn't recognize the device, please ensure that the USB boot tool is running on your host computer. Gumstix provides a custom Yocto Linux disk image for use with the Raspberry Pi CM4. Please visit the Upverter website. There is a download button for AutoBSB. Once you extract the files and open the unzip folder, you will see the README file. Open a file, and if you see the link section, there is a list of image links, and I'll try to get the desktop full image. Please don't close the AutoBSB folder. We're going to use some files after we flash the image. If you have a Linux OS, you can write an image to the eMMC from the terminal. First, run lsblk and check where a new device appears. In my case, I found the compute module in /dev/sdb. It could be another location, so it would be a good idea to run lsblk before rpyboot to see the changes. Also, it is very normal to have no partition if it is the first time that you boot the device. Now you'll need to find a directory that has a raw OS image and cd into it. Finally, to write the image to the device, follow this command. Please note that you need to change /dev/sdb to the appropriate device, and you cannot undo once you enter sudo dd command. It'll remove all the original data. The process of writing an image will take a few minutes depending on the image file and host computer. In my case, it took about 20 to 30 minutes to write the Gumstix Raspberry OS Buster full image to the CM4. Once the image has been written, unplug and replug the USB, then you should see two partitions appear in /dev folder, which means it can be mounted normally. Now let's go back to the AutoBSB folder that we got from Upverter. There is a compiled version of the device tree overlay in the boot sector called Upverter.dtbo, and we're going to use this file. With the CM4 still connected as a USB drive, copy Upverter.dtbo to the overlays folder on the boot partition of CM4. Once you copied all these device tree files, open the file names config.txt. And then comment out all the lines starting with dt_param and dt overlay. And add the following lines. AutoBSB delivered a custom DTB overlay for Gumstix CM4 designs, incorporating the device tree features required by the kernel and many drivers. Additionally, you can add the following lines to enable the USB host bus. Also, there's another file called dtblob.bin, which is for camera support. This is also supposed to be in the boot sector, so let's copy and paste this file to the boot folder of the Pi. Now we covered how to set up the CM4 for both Windows and Linux OS. So the question remains, how would you connect the Gumstix Development Board to your host computer? Our next tutorial will cover 3 different ways for the connection, and I hope to see you on the next video.